Well, greetings, students. Today we're going to be finishing up the drill tap bore project. You'll see it on my screen here. Um, so far, you should have finished the center drilling, the 257 drilled holes, the 5/16 18 tap, and the contours, okay, including the counter bore. So your program should look like this. Let me slow this down a little bit. It's a drilling operation. Let's start it again. Let's start with the center drill operation, and then we do the drilled holes. Speed this up just a little bit more. 3 holes in the center for pilots, and then tap. Now it's bore and counter bore. And if you'll notice over here, it's 1" 12 thread, and we know that our minor diameter is 9/21/9 right here. That's our minor diameter. Look at the top view here and click off of this. 9/21/9 is our minor diameter. The 1" here is our major diameter. And our counter bore, of course, is 1.250. All right, so there's a couple things we want to still do yet. As I was saying in the classroom last week, there are times when you are working on a program and you say to yourself, oh, I forgot to do an operation here or two. So at this point, we've done everything except for 2 things. We need to thread the hole, and I also want to show you how to face this part. As you all know, when you buy material, this is 1" material, but a lot of times if this were made of something that was not, let's say, cold rolled steel, which this is, and it was, let's say, tool steel or something, you would have to get it oversized, maybe 20 or 30 thousandths, maybe 1/8 of an inch. So many times there is a requirement or a call for face milling. We don't have any face mills. You may not have a face mill made up. If I look in my category here, I do have a face mill, and I do have a 0.0833 pitch mill, which is 1" 12. So if you take 1 divided by 12, you get 0.08333. So how do we make these? Well, if you look up here to the top right, you say, it says add a milling tool or a turning tool. Over here, you have face mill. You can click on face mill, and hopefully you won't get that. Well, anyway, until that happened, I guess that happens sometimes, but you can go up there and you can create a tool for yourself. So if you wish, you can go up here and you can go to milling tools and you can click on face mill, or you can create a threaded mill, just like the one you see right here, 0.0833 pitch. So you'll have to look down through here, chamfer end mill, dovetail, thread mill. Right there is thread mill. So you'll go in here and you'll put in the necessary information. So you should put down here that it's a 0.08333 thread mill, and I have it number 6. Okay, So let me get mine out of here so you can see it. So under my general, I have 0.0833 pitch and thread mill, number 6 tool, on for the coolant, clockwise direction, 100 thousandths off the face of the part, initial clearance, and I have it at pink, okay, as my simulation color. Under the wrench here, which is your settings, you want to have home, home, and home, as we've talked about in class. Also, you want to make sure that your Z plus is at the top home position. And then as far as the holder is concerned, they call it the extension. This should be 2 inches. This should be 3 inches. This should be 2 inches, approximately. And then under the shank on a thread mill is always going to be smaller in diameter than the actual thread diameter. So I have it at 736. Again, it remembers the 2 inches. And the actual length of the thread mill, where the threading takes place, is 1.250. So the last one here, the last category, is actually one of the most important categories. You must make sure it says thread mill here. The tool diameter is 3/4. It's a 60-degree thread form included. And the pitch is 0.08333, just like we calculated for a 1-inch 12. No taper angle. Cutting length 1.250. 4 flutes. Again, the shank diameter is remembered here, 436, and the tool length is 2 inches. All right. So that basically says, and you can say okay on that. For your face mill, you should put down here 2-inch face mill. We have one out in the shop. It's 2 inches, so you'll want to put 2 inches here under tool ID, 2-inch face mill. The tool number I have is 5. Coolant on, clockwise direction, 100 thousandths off the face of the part. Again, under the settings, it's home, home, and home. Again, Z plus is home position. Now this is where things are going to have to change a little bit here, because the thread mill, the kind that we have, has an angled insert like this. So again, the shank is 2.750. The length is 2 inches here, and the actual part of it sticking out of the holder is 1.250. And then for the type, it's a cylindrical. The shank diameter is going to be just under 2 inches. And our length of this sticking out, it remembers it at 1.250. And the cutting length down here is 3/8 of an inch, 0.375. And that's because of the insert, the length of the insert when it's on an angle. And then the last category is going to be important because you want to fit your insert in there. So the tool diameter again is remembered at 2. The bottom clearance here, right here, how far is this sticking out? 0.0625. The orientation angle is 10 degrees. 375 again, it remembers that. Tool number 4. I'm sorry, inserts 4 of them. And the shank diameter is 1.875. It remembers that. And the tool length is, again, remembered at 1.250. The insert now is the next thing. It's a rectangular insert, not square. It's got a corner radius, which is important right here. This radius is 0.0315 or 032, a 30-second radius. Insert width, 3/8. And the length of it is 0.5. So you should fill those things in there and say okay. So now we have a face mill and we have a 0.0833 pitch thread mill. So now we're basically ready to do the rest of this project. And as I said earlier, sometimes you say to yourself, I forgot to do an operation. Esprit allows you to easily add an operation later on, even though you've finished all this other stuff. you can do your face milling operation and put it up at the very, very beginning if you want, and I'll show you how to do that. The thread milling operation should be the last operation anyway, so that's going to be fine. As far as our project manager operations, the order of this is going to be center drill, a drill, a 5/16 18, and then the 3/4 inch finish end mill will be for all of the contouring of the through hole and the counterbore. I think it's important for you to understand that the project manager settings under operations here shows it sequentially of what's going to happen first, second, third, fourth, fifth, sixth, seventh, and so on. If you go to the feature, it is not necessarily in order. So it's important that you understand that this is a feature category here, and this is good for picking up chains. Notice you see how I click on these chains, and that tells me where these chains are that I had created earlier. So this is good for picking a chain. But for operations, sequence of operations, you should be in your operations category here. This is something to remember for the future. All right, so the first thing I want to do is I want to add a face milling operation here. So what I'm going to do is I'm going to make sure that I have a chain all the way around this perimeter of this part. If you don't have one, create one. All you have to do is go up here to manual chain, start here, click there, click there, click there, and come back and close. And now you will have a chain here all the way around the perimeter. The reason why you want to create a chain around the perimeter is actually for two reasons. Number one, and most important reason is that you can let Esprit know what you're going to face mill. So really, we want to face mill this whole perimeter of this part. So we create the chain around the perimeter of that part to tell Esprit that's where we want to do the facing operation. The second reason is for doing simulation parameters. Under here, it says up here in simulation parameters, we're going to create an extrusion here. We're going to create a color here that will be 1 inch from the top down to represent the part, and it'll be a gray color for me. And we will use that then to see our machining operation a lot better. So we'll talk about that in a couple of minutes. So the first thing I want to do right now that I've created this chain is I want to click on the chain, and I want to say machining, solid mill traditional, and you'll notice the very first category is facing. So I'm going to go up here and I'm going to look at this, and I'm going to put face mill in here. I'm going to put a speed and feed, and that's fine for now. Constant removal rate, no. Use feed and speed, knowledge base, no. Strategy, zigzag. You'll notice you have climb milling, you have conventional milling, and you have zigzag. I always use zigzag because if you use conventional or climb, it's going to go across, lift up, come back, drop down, go across again. That's a lot of work, a lot more time. So if you do zigzag, it's just going to do a zigzag like this, and then you're finished. So I'm going to choose zigzag. One pass, no. Optimal cutting angle, yes. Bridge movement, segments. So you don't want arcs. If you do arcs around the corners of that rectangle, you may miss the corner. So I always use segments. Step over, I have as 1.250. So my face mill is 2 inches in diameter, plus or minus, right? I'm going to step over 1.250, so that's a little bit more than halfway as far as the width is concerned. So that's 62%. Notice they have step over amount, and the percent is there. For the overhang, an end mill, face mill has to overhang the outside edge of both of these ends. so that it covers everything and makes sure that it machines the edges. So I have down here overhang 0.5, which is 25%. The bridge percent of feed rate is 100%. Overhang direction both ways. You can do it one way, but then it's not going to go over. It's not going to overhang on both sides, and you want it to overhang on both sides. So I choose two ways. Include islands? No. And this is important. Stock allowance on the floors. If I have a piece that's, say, 1.125 thick, you notice the piece here finishes at 1 inch. So let's say that our material is 1.125 thick. Well, then we should split that in half and take half off the top and then flip it over and take the other half off the bottom, is what we do in machining practices. So we can put 25 thousandths here if we're going to make it, or you know, if I said it's 0.62, yeah. If we take 125, we can make 0.0625. 0.0625 would be half of 125 of that extra material. So then we come down here and with the total depth is going to be 0. And you say, well, Bob, why is that? Well, because we want this to finish at 0, meaning Z0, the top of the part, at 1 inch. So we want to leave that at 0. There is no incremental depth. We're going to take a swipe at 0.625, and we're going to start depth at 0. Sometimes you have to face mill at the bottom of a pocket or something. If that's the case, then you'll have a starting depth of minus something. Minus a quarter of an inch or minus a half an inch, and then you'll be face milling down at in an area below the Z0. That's what the starting depth value here is. Of course, it's 0 in our case. And then we have full clearance, 1 inch. Clearance value is 100 thousandths. Return plane and retract plane is clearance. Entry mode, down and over. So we're gonna we're going to come down and then feed over into our start, okay? And then we're going to lead in at 1.1 inch. That's important too. I'm going to come in at this side and I want to make sure that my tool is not going to crash into this thing when it comes down. So my lead-in distance is going to be at least more than half the tool. If the tool is 2 inches and I have 1.100, then I know I'm clearing it. And then it should be for exit mode over and then up. So I want to feed over and then get out of there. Go straight up and out of there. And I'm going to say OK. So if I simulate this, I'm going to put this on 3D here and go ahead and simulate the tool. You'll see I already have my simulation parameters set up. But you'll see now that I'm going to go across here and I'm going to face this off like that. So that is the first face. Then we turn this thing over after we deburr it and we finish the face on the other side. So how can we make this simulate to make it look like we're going to actually be facing some material off? Well, if we go into simulation parameters over here, we want to put in here, first of all, we want to select the feature. So I'm going to get rid of this. I'm going to say delete, and I'm going to say update, and I'm going to get out of there so I can start fresh with you. So I'm going to go to options and then solids, and I'm going to say extrusion, and I'm going to extrude this thing down. So the Z plus is always Z0 plus, right? And the Z minus here, it has the minus there. It's 1 inch down in this case. Well, the 1 inch down is perfect because that's the final finish of the dimension of the part. But since this thing is 0.125 thick, I'm going to put 0.125 up there so that it sticks above 1/8 of an inch. And then I'm going to click on the chain. It says select feature. So it's asking for the chain. So I'm going to come down here and I'm going to pick the chain and say yes. And I'm going to say add. And you'll see stock 1 in there. And then you hit OK, and that takes care of that. So if I do the facing operation now, I will see material being taken off. You see this? I'm taking a 1/16 off. And if you look carefully here, you still see there's this 0.625 left to take off the other side. So now we're going to make another facing operation that will take care of the other side. So we're going to face this side, we're going to deburr, flip it over in the vise, and then we're going to take another 0.0625 off the other side to bring it to Z0. So again, I'm going to go up here to I'm going to first of all click on the chain again, and then machining, solid mill traditional, facing, and this time everything's going to be the same here with the exception of this. The stock allowance on the floors now is no longer 0.62, it's 0.0 because that's going to be the finished size or total depth of 0. And now if I hit OK, now I'm going to have two facing operations. So I'll do the first one, and then I'll do the second one. When I do the second one, you're going to see the geometry, aren't you? Right there's the geometry. You can see it now. And you can see it's taken everything off. That means that when you do your second cut, you should see the geometry of the actual part itself. And if you see the geometry is always on Z0 when we created this thing. So this is what we want. We want to see the geometry here when we make our final cut. Now you say, well, we're doing this at the very end of the operations. How can we fix that? Well, if you will take your cursor here and put it about where my cursor is, and you left click and turn it blue, and then press down on your key, on your mouse, and just hold it down and drag it up. Notice I have a red line. I bring that red line all the way to the top, and it moves my first face milling operation right to the top. Now I'm going to do the same thing with the second one. I'm going to drag it up and put it directly underneath the one above it, the first one, the first face milling operation. And then I'm going to double check just to make sure that the first one has 62 thousandths left over, and it does, and that the final one here has a 0 for stock allowance, and we do. So now if we look at this and just do our first two operations, let me slow this down a little bit here, and let's do our first two facing up. There it is. You see it? So when you create the NC code, you're going to put a stop in there, an MOO stop in your NC code after the first facing operation. So you'll do this one here. Whoops, let me do that again. You'll do this one first, okay? And then you'll put a stop, an MOO, in your program so that you have a chance to take the part out, deburr this edge, flip it over, and then put it back in, and then finish facing the second side, which will bring it to thickness, 1 inch. So that's how we can move an operation from down here. Whenever you create an operation, it's always going to add it to the bottom, which you saw happening with the facing. They ended up at the bottom of the last sequence. Well, we want to change that and make sure that it's the first sequence that takes place. We want to face mill this before we drill and tap it and do all the other operations. And then we said that we were going to do some thread milling. All right, so thread milling, we will go ahead and do that now. So we'll turn this to top view. We'll zoom in on this, and we want our thread mill to follow the 1 inch chain. Should have a 1 inch chain that has the dotted geometry directly underneath it. And you say yes. And you capture the 1-inch diameter circle. Then you say machining, solid mill traditional, and come down to threading. So now we need to put in, first of all, that we're using the 0833 pitch thread mill. So you pick that up, put that in here, and then you'll put in your feeds and speeds. I have 500, 10, and 10. That's plenty good for now. It's an internal right, so I'm going to be going in a clockwise motion, so I'm going to be staying to the right of this profile. So as I'm going clockwise, I'm going to stay to the right of the profile to create the thread. So that's why it says internal right. You have external right, you have internal left, we have external left. This is an internal right-hand thread. The major diameter you type in here, which is 1 inch. And then the 921.9 should appear because Esprit has some knowledge base involved in this. But if not, you type in 921.9 and 1 inch here for the major diameter. The total depth, 1.050. We want to go just a little bit past the depth of our part. We know our part is 1 inch, so we want to go just past a little bit more than the bottom of the part to make sure that our thread goes all the way through. The starting depth is 0. So we're not going to be starting down below the surface or anything, so the starting depth is 0. The strategy is conventional. Conventional means that we are pushing the chips away, so we're going to be going, as you're seeing here, in a clockwise direction, and as we thread, it's going to be moving down. Each time it makes a revolution, it's going to penetrate, when it goes down to 1 inch 050 deep, it's going to make one complete revolution, but while it's making the revolution, it's going to penetrate 0.08333. At that point, we will definitely be through the part. So that's what we're doing. Conventional, we want to machine down. We want a transitional move of rapid. So the start angle is 180, so we're going to be starting over here at 180. We said before that if this is a Cartesian coordinate here, this would be 0, 90, 180. And that's what we're having to do here. We're going to be starting this at 180, so it's going to come down, and it's going to approach at 180, and then it's going to go around in a circle clockwise direction. Again, there are arcs here and there are segments, little tiny segments. It'll just go around and make little tiny segments until it's done. It takes way too long to do that, so we always use arcs. The tolerance is 1/10. Number of rotations, we want 1 rotation. So this is going to have to go down below the part, 1 inch 050, and then make 1 revolution. And that will put the thread in there at the pitch of 0.0833. All right, so down here we want to say offset tool radius, yes. Cutter comp, right. Offset register, 6. Notice that we're not going to use half of the 3/4 inch diameter thread mill. We don't have enough room to do that in here because the hole is only 921.9 and a 750 end mill or a thread mill is just about that size. So we're going to do center point programming here on this, and for all intents and purposes, when we do CAD-CAM, we always do center point programming. All right, so the last category is links. The clearance, again, is 100 thousandths. Return plane clearance, start, end, center hole. That's very important. If you don't put yes here, it's going to start wherever it wants to. We want it to start in the very center of this hole. So start end is at the center of the hole. Lead in. We want to radially lead in. We don't want to just ram in and then go around. We want to radially lead in so we get a nice smooth finish. Clearance is 20 thousandths. The feed rate, entry feed rate is 100%. And okay. So now we have a threading operation. If we put this on isometric and we just pick the threading operation and single step it, you'll see that it's going to go down and then it's going to make a rotation. And by the time it's done the rotation, notice it has 1.050 here at the bottom left. And that's what we want. So your assignment then for tonight, or today rather, is to finish up the rest of these pockets. In other words, you're going to do the face milling operation just like I did, and then you're going to do threading of this one, and this one. So that's the rest of your assignment for today, and we'll see how you make out with that when you get back to class, or if you're not going to be at class anytime soon, you can send this to me and I will look at it and give you a critique of it to make sure that you're doing everything correctly. So maybe we should do it that way. Maybe you should just email this back to me, just this file, and I will take a look at it and let you know how it turns out. All right, well, have a good day and talk to you soon.